Good afternoon, everyone. Let me introduce myself. My name is Subiyantoro. I'm a government employee from Indonesia and currently work in Ministry of Public Work and Housing. And also I'm a student in University of Twente. Today I want to present about at glance the regional and local Landslide early warning system in Indonesia. This slide is I work together with Mr. Ragil Juniawan, my college. This is the outline of this presentation. I will present the background and the existing operational regional landslide warning system, and the proposed new rainfall threshold and warning level, and the existing local landslide warning system, and the development of the new local landslide system in Indonesia. And then the end session, I will give you the conclusion. Indonesia is a country that very vulnerable with the disaster. We can see this map show the color. The red is the red color is the area that the frequency the disaster more than 150 in a year. So Indonesia, the most common hazard are flood and then tornado and landslide. And the second deadliest disaster in 2020 is landslide. It resulted more than 100 deaths in just 1 year. And we can see that in Java Island, the most populated island in Indonesia, is have the frequency is more higher, the landslide. This is one of the example of landslide in Banjarnegara in Java Island, and we can see the trend of the landslide occur and the victim that time by time the occurrence is increased. And then this is the page I want to show you about the existing operational landslide warning system, the regional one, and you can access with this website. And this is the landing page that you will see. This landslide warning system is operated by Balai Sabo since 2015. The Balai Sabo is part of the Ministry of Public Work and Housing in Indonesia. And this system is collaboration between the meteorological, climatological, and physical agency in Indonesia, and the others in Netherlands, and also the Muhammadiyah University of Yogyakarta. But unfortunately, today the system is still under maintenance, so it will show the result, but it will be inaccurate. So because some trouble in the rainfall forecast. Okay, I will show you a little bit how the system built. The system is built by 4 main components. The one is satellite rainfall estimate for GPM, the previously called TRMM, and then the forecast rainfall from meteorological agency in Indonesia, and then the rainfall threshold, and the last one is the susceptibility landslide map. And all together combined, we utilize LEWS flood early warning system platform from the Netherlands. This is how the system works. The rainfall, we use rainfall threshold, but only we define as very simply just from median of 1 day and 2 days precipitation data, and when we just connect it, and we have two threshold for 1 day and 3 day cumulative. And these two threshold, combining with the susceptibility map from entire Indonesia with a scale to 250,000 in scale of very big scale. And when one threshold is exceed, the yellow sign will appear. So one of these threshold exceed, yellow sign will appear. Then if both of the threshold is exceed, the sign will be red. That will very dangerous. And then this is kind of a success story. The capability of the our system is the predict very well. In 20 February, we predict for 3 or 4 days in advance that there will be landslide in Brebes area, and then in that day, landslide happened. That's one of the example of the capability of the system. And of course, the alarm, the miss alarm is quite a lot, and false alarm, false positive actually. So there's so many miss hit, and that's why the system need to be improved. And my college Uniawan 2022 proposed the new rainfall threshold and the existing warning level. Because we use all the entire network use only single value of threshold, and we did not separate in susceptibility map the moderate high and very high susceptibility map. So we have to improve it. We have to detail it. And Uniawan proposed this one. If in the existing system, we did not separate the yellow, the orange and the red one. So it will be have same behavior when rainfall occurs. So and also in the green zone, in the existing system, the green zone is ignored. So there will be no warning issue in the green zone. But then we propose the new classification, and we consider all the zone in the map, susceptibility map. And this one is have tested in part of Java, and the accuracy quite good, about 65% the hit rate. And then move to the local landslide early warning system. This is the typical one of the local landslide early warning system used in Indonesia. That they use mechanical, they use mechanical instrument like a extensometer, rain gauge, water pressure sensor, tilt meter, inclinometer, and backward camera. And the system have been implemented in Indonesia since 2008.
You have 3 minutes.
Okay. Starting with the traditional device into using real-time monitoring system. And the interesting one is Indonesia is a built with the good community. So Gadjah Mada University have a standard that right now become to be an ISO as a standard for early warning system in the world. And the main issue that they bring is a community base. Was it that the idea is that community have to be a part of the system and have to know how it works. And the guideline adopted the concept of the people-centered of early warning system. So we not just focus on one tool, but kind of interconnected system to be have a good early warning system, because the community is very important part of the system. So they have to be involved. We can see in this picture, the left picture, this one is how people, the citizen, build their map. So they guided by the expert to build their risk map. So the map is not provided by government, but they build by themselves with the guidance. And this one show one of coordinator present the map to the communities, and the map, evacuation map route, is placed in the public area, so everybody will across there can read the map. This is sample of the student to see the evacuation route map. Sometimes the route map is not using a standard language or standard signal, like you can see this picture. The north, the U is north is not a row up but a row down, because they and the people is more aware where is the north and where is the south. If we have to change this upside down, so they will confuse how we have to evacuate like that. And then currently I'm with my college develop the new kind of lesson early system, because we know that with the regional, the coverage area is so big, and the resolution of the map is also so hard, and the single value of rainfall threshold, we need to improve the system, and that initiate collaboration between Indonesia and Netherlands government to
go to the conclusions, please.
Okay, kind of a project to build new system of landslide warning system, and this is the purpose that mainly we use physically based and combining with machine learning. That's and the other thing is we want to collaborate the soil moisture and the rainfall, not only on rainfall but with the soil moisture. So I come to the conclusion that landslide warning system in Indonesia is crucial, and we know that government and academic institutions are eager to continue the development and develop of better landslide warning system. That's bring me to the end of the presentation. And this is the reference, and I make my contact. Thank you very much.